Warm greetings. The South African Mathematics Foundation, abbreviated SAMF, conducts on an annual basis several competitions, mathematics competitions, aimed at high school students. The junior students, that means from grades 8 to grade 9, as well as the senior students from grades 10 to grades 12. These are all Olympiad type questions. In addition to these Olympiad examinations, tests, competitions, the society also conducts team competitions. The mathematics Olympiad papers run over 3 rounds, rounds 1, 2, and 3 for seniors and juniors. And the team competitions have an individual as well as a team paper, where teams of 10 tackle these problems, the team papers, simultaneously. So out of these 8 different types of problems each year, we will be running a series of deliveries of this type, sessions. We do 7 of them. We don't do the senior 3rd round paper, and over a period of 3 years. So there are 21 such papers. Today, we are going to do the senior individual paper, which was conducted in 2023. The 3 years that I mentioned were 2023, 2024, and 2025. And this is the first of the senior individual papers that we shall be discussing. So with those few words, we go straight to the paper at hand. As you can see, it's the 2023 team competition senior individual. Okay, so let's go to question 1. As you can see, question 1 gives you a sum of fractions all equal to 2023. And the problem is to find the number n. Evidently, n is an integer. As you can see, they are increasing from 1, 2, up to n minus 1. The numerators are. The left-hand side has got a common denominator, n, so we can put that down. And when you simplify this, you get the denominator is n, and at the numerator, you have the sum of all the integers starting from 1 going up to n minus 1. Now the formula, there is a formula for the sum of the first natural numbers, and it is the sum. I think all Olympiad enthusiasts should know this as one of the fundamental formulae, the sum of the first natural numbers. It's n into n plus 1, the number of terms times its successor, n plus 1, divided by 2. All right, so this will be n minus 1 sorry, let me just rewrite this. The numerator is n minus 1 times n, because the number of terms is n minus 1, over 2. While the okay, so these n's will cancel, and you have n minus 1 equals 4046. So n is equal to 4,047. Just hold on for a minute, please. Sorry about that. I've forgotten to switch my telephone off. So I've solved all these problems, and I will show you my solution, which may sometimes be different from what I do here. So you can see the solution is written out in full, and we get the same answer, 4,047. All right. The next problem says a hexagon and a pentagon, or hexagon and a pentagon, share the property that the side lengths of each of them are consecutive integers, and the perimeter of each is 45. So the question is, what is the difference in centimeters of the short side and the pentagon and the short side of the hexagon? So I've drawn these pentagons. A pentagon is a five-sided figure, and it is said that the sides are consecutive integers. So in other words, if the smallest is n, say, then the next one is n plus 1, n plus 2, n plus 3, and n plus 4. And here, those are the sides of the pentagon. And here, the hexagon also has got consecutive integers as its sides. It goes all the way up to n plus 5 now. And it says that the perimeter of each one of them is 45. So when you add up all these consecutive integers, you're going to get 45. All right, so if you add up these, you've got 5n plus 1, 2, 3, 6, 10. 5n plus 10 is 45. Divide by 5 right throughout. And here you have 7. Right. So the pentagon has got sides 7, 8, 9, 10, and in 11. If you add up all these, you will get 45. Okay. So it's the pentagon, the sides are that. While in the hexagon, you've got 6 m's. When you add up all these, and now you have 1 plus 2 plus 3 plus 4 plus 5. So that works out to 15. And that's also 45. Both of them have got the same perimeter. All this time you can divide by 3. 2m equals 10 and m equals 5. So the sides of these are 5, 6, 7, 8, 9, 10. Six-sided figure. And the value of m is 5. So what is the difference in centimeters of the short side? The short side is that one, the shortest side. And the short side of the pentagon is 5, 7. And of the hexagon, the short side is 5. So the answer is the question is, what is the difference between these two short sides? It has to be 7 minus 5, which is equal to 2. Okay, so that is the solution to question 2. Clear the drawings and get on to the next slide, which gives you the answer. Well, of course, you can see here the difference is 2 right at the bottom. I usually expose these solutions because you can freeze it and take your own time looking at it. All right. So let's get on to the next question, which is question 3. A 2-digit number x is twice the 2-digit number y. The sum of the digits of x is equal to the products of the digits of y. The difference between the largest and the smallest digits of x is equal to 1 of the digits of y. What is the value of x plus y? There's hardly any information is given here, and it's quite a tongue twister. Okay, these 2-digit numbers, or any digit numbers, I usually write it as, instead of writing 123, if I write symbols A, B, C, then it looks as if I'm multiplying these. So what I do is, when I'm referring to the 3-digit number, I put a square bracket around this, right? So the square bracket means these are the digits. The ABC by itself is actually equal to 100A plus 10B plus C. A is the 100th unit, B is the 10th unit, and this. Okay, it's not the product of ABC, so we actually mean that this number is that. Okay, so you got a 2-digit number x. Let's write down, let x be equal to the 2-digit number. Let's call it AB. And y is also a 2-digit number. Sorry about this. Y is also a 2-digit number. Okay, it's given that the sum of the digits of x the digits of x are a plus b, these are the digits, is equal to the product of the digits of y. It's equal to the product of the digits of y. But I should have said first that the 2-digit number x is twice the 2-digit number y. So when you take x, its actual value is 10a plus b, and that is twice the value of this, which is 10c plus d. CD is the number, the actual value of this 2-digit number is 10c plus d. So you also have a plus b equals to cd. So this is 20c plus 2d. All right, so you got 2 equations in 4 unknowns. Right, so you need more information, and somewhere along the line, they give you some other information. But so the idea is to reduce the number of unknowns. One of the ways of doing that is, you can see on the left-hand side, I've got b occurring twice, so we can subtract those 2. The 10a minus a is 9a, b minus b is 0, and you get 20c plus 2d minus cd. But that doesn't help you too much as well, because now you've got three equations. I mean, one equation in three unknowns. Now, this kind of an expression here with a C and a D and a CD, often there's a way of tackling these problems. What you do is you remove the C or the D, if you like, from CD and another term. If I take C, for instance, I can say this is 20C minus CD plus 2D. Okay, CD. All right, let me just create some space here to do some work. Oh, sorry. Okay, so you have, when you write it like that, you sort of group the C's together. You get 9A, and take out C as a common factor. C into 20 minus D plus 2D. Now, the 2D, what you do is you create a 20 minus D again. Right? Now, the plus 2D, you can squeeze it in between here somewhere. And instead of plus, I can put a minus sign here. And the 2D, I can put a 2 in front. So you have minus 2 into 20 minus D. This minus 2 times minus D is plus 2D, you see? So this is taken care of, that is taken care of, that is taken care of. Right? Now you got 20 minus D, which is a common factor. But the problem is that I've added something here, which is minus 40. And it wasn't there. So I have to add 40 to nullify it to this expression. So the nice thing about this is this factorizes as C minus 2 into 20 minus D. Right? But this minus 20 times 2, I have to add 40 to make this thing equal. Right. Now I've got a product, you see. So if I put the product on the left-hand side, C minus 2 into 20 minus D, and that is equal to 40 minus 9A. All right. So that is what you've got, 40 minus 9A. Now there is something else here. You see, they say this two-digit number X is twice this number here. So this number is twice this two-digit number. Which means that C cannot be too large. C can't be 5, for instance, because then twice a number which starts with 5, a two-digit number, would be a three-digit number. So C can't be as much as 5. C can be 4, and C can't be 0, because this is a two-digit number. So it's not a one-digit number. So C, it starts at 1, and its values are from 1 to 4. So that is a very important observation that we can make to proceed from this. I want to just take out all these now to create some space. So what I have here is that the value of C is, for the reasons which I just outlined, C is equal to 1, 2, 3, or 4. So that's limited to There's just these four values. I'm going to try to put C equal to each one of these and see what I can make out of this. All right, let's C be equal to 1. I'm going to look at my equation and see what happens. So C equals 1 means I got C 1 minus 2 is negative 1 into 20 minus D. That is equal to 40 minus 9A. Now these numbers, 40 and minus 20, gives you 60. So you can say this 9A, if you bring it to this side, become plus 9A, plus D is equal to 40, minus 20, you bring it to the other side. Now remember, D is a single digit, right? The A, B, C, D are all digits. They are numbers in a two-digit number, or two-digit numbers. So they are digits from 0 up to 9. So now you've got 9A plus D is 60. So what must I, or if you want, you can say 9A is 60 minus D. So the question is, what must D be so that it's a multiple of 9, you see? 9 times something is 60 minus D. And D is a single digit. So the 60 minus D will be something between 50 and 59. It's a single digit. And you're looking for a multiple of 9 between 50 and 59. And the answer is 54. So 9A is 54. So then in this case, A is equal to 6. 9A is 54. A is equal to 6. And I just want to check something here. And D is also equal to 6. So you got these two values. And remember, we had and we say that C is equal to 1. So your number CD, your two-digit number CD, is equal to 16. 1, 6. And AB, X, just remember this, X was AB, Y was CD. So this is 16 now. And this X was 2Y. So then X is 32. So this is your Y, and X is 32. The sum of the digits of X, 3 plus 2 is 5, is equal to the product of the digits of Y. And that's not the product. There's something wrong here. The product of the digits of Y is 6. So how did I get this? So somewhere along the line, I seem to have made a mistake. When C is equal to 1, somewhere along the line, I made a mistake. Our original equations were 10A plus B That's your x is equal to 2y. So there's 20c plus 2d. And then you had a plus b is equal to cd. You had 9a equals c into 20 minus d. Right? Oh, so this was plus 2d. Oh, yeah, no, that's okay. So when you subtract here, you get plus 2d. So 9 into 20c plus 2d minus cd. That's correct. And I'm adding minus 40, so I add 40 to the side to make them equal. And you get 40 minus 9a. Yeah, I'm not sure exactly what went off here. When c is equal to 1, uh, c equals 1, you get 9 9a if c equals 1, you got minus 1 into 20 minus d is equal to 40 minus 9a. So you got 9a plus d is equal to 40 plus 20, which is 60. So that looks okay. So d has to be, oh, I see. Yeah, d can't be. Yeah, this is more than 60. So d is actually 9a is 60 minus d, and yeah, d equals 6 is not what we're looking for. We want this to be 60. At a multiple of 9, so d is equal to 6. I'm sorry, I can't see what the error is. But let's have a look at what I've written here. So what I got, c equals 1 is 9a minus 40. Oh, I see. This was 20. But the other factor was d minus 20. Okay, look, it was actually 9a was equal to 20 plus d, not 60 plus d, because this was d minus 20 on the side. Okay, I'm sorry. So we should have been here, not 60 plus d, um, as we 60 minus d, I said. So it's actually this. So you got a multiple of 9 between 20 and 30. So that's the only one is 27. So d will have to be 7, you can see. And we already know that c is equal to 1. So the cd would have been would be 17. See? And double that would be 34. So that is how you got these quantities, because c is equal to 1 here, you see, and d is equal to 7. So that two-digit number will be 17 and 34, and that certainly works, because 17 and 34, when you multiply c and d, you get 7, and when you multiply add 34, you get 3 plus 4 is 7. So that figures. So, and the question was, what is x plus y? It has to be 17 plus twice itself, which is 34. That gives you 51. So that's the answer. And when you try c equals to 2, you find that, I'm going to look at my solution here now. If c is equal to 2, this becomes 0 here on this side. Let me highlight this thing. Sorry about this. I made some kind of an error here. So if C equal to 2, if you go into this equation here, you get 0. Yeah. So 9a minus 40 is 0. 9a is equal to 40. And that's impossible because no multiple of 9 is equal to 40. So C equals to 2 leads to no solution. When you try C equals to 3, you'll see, again, if you go to this now, you get 3 minus 2 is 1. So you have 9a minus 40 is equal to 20 minus d. And this is the equation that we actually land up here. C equals to 3. Eventually you get 36, and then double that is 72, and that doesn't work as well. You get B equals 12, you see, and B is a single digit. So C equals 3 doesn't work. C equals 4 leads to these, which certainly is a solution. But they also say that one of the digits is 1. So this can't be the solution. In any case, when you work out, I say this is not a solution because 0 is equal to 4. I can't see why we actually say that. All right, but this is not a solution because why? One of the digits is 1. And that is the reason for that, to reject the solution. You see, they do give you a small piece of information here in the previous thing. They said the difference between the largest and the smallest digits is equal to one of the digits of y. And that is why I said 0 is not equal to 4, because the difference between those those digits is 0, you see. The difference between the digits here is 0, and that's not equal to one of the digits of y. So this is not the solution. All right, so there's only one solution, and namely 51. X plus y is 51. Okay, I'm sorry, I made some kind of a calculation error there. I'm sure you'll be able to pick it up. So let's go to question 4. One solution of the equation, here you've got a product of 4 numbers equals 9. And these 4 numbers, A, B, C, D, are different integers. These are integers, A, B, C, D, not real numbers. Not like square root of 2 or something like that. They're all integers and they're different. And one of the solutions is x equals 2. So what does that mean? That means when I put x equals 2, it will satisfy that equation. So let me put x equals 2, because that is a solution. So I can have 2 minus a times 2 minus b times 2 minus c times 2 minus d is equal to 9. All right, so you got 4 numbers, all of them are integers, and they're all different because a, b, c, d are all different. And if you keep subtracting them from 2, these 2 will be different. You got 4 different integers multiplied to give you a 9. Now, you might think, well, how can that be? You can get, at most, you can get the different factors for 9 are 1, 3, and 9. So how can you get 4 different numbers adding up to 9, multiplying to get 9? The answer is actually lies in the fact that these are integers. So it means you don't have to just take the positives. You can have negative numbers as well. So this is so if you look at 4 different factors of 9, which are all different, including the negative numbers, you can put 1 and minus 1, and 3 and minus 3. You see, these are all different, and if you multiply them, you get 9. Are the values of these factors: 2 minus A, 2 minus B, 2 minus C, and 2 minus D. The question is, what is A plus B plus C plus D? So if you add all these things, add all these 4 factors, you're going to get 8 minus A minus B minus C minus D when you add all of this. And when you add all these, you get 0. Why am I adding? Because I see when I add here, I get this thing that I'm looking for. So I don't have to calculate each one of them. I can see I really need to know this. And I observe that if you add all this, you will get this thing here. You see? You get A plus B plus C plus D. If you take it to the other side, it's equal to 8. Where did I get 0 from? Because this set here is the same as this set. These are the solutions. 1 minus 1, 3 minus 3. When you add them, you get 0. Okay, so that requires a little bit of insight. And a little bit of arguments and logic. Okay, let me just see what the solution was. Yeah, so this is the same thing. I'm exposing the solution here. Well, we go on to question 5. The right angle triangle ABC has its right angle a point C. Okay, you can see all this. It's also given that M and N are the midpoints of these sides. So you can see this equals that, this equals that. It is given that AN, this thing here, this median, right? This is a median, a joint pointing, I'm sorry, joint, a line joining the points, the vertex to the midpoint of the opposite side. That's called a median. So AN is equal to 19. And BM is equal to 22. This one equal to 22. Okay, I think I can get equations here because this is, if I say these are equal, let's call them AA, and these are also equal, call them B and B. Now you can have equations because AN is 19, and you got a right angle triangle, yeah, whose sides are 2A and B. The hypotenuse is 19. So when you square this, 2A squared plus B squared equals 19 squared. That's AN. And if you look at this triangle here, this time you have A squared plus this squared, which is 2B all squared, is equal to MN squared, or MB squared, or BM squared. That's 22 squared. Okay, and if you rewrite this, you'll get 4A squared plus B squared equals 361. And this is A squared plus 4B squared is equal to, maybe I'm not going to square them and multiply all these answers. I might be able to just leave these squares intact, and I might be able to find an easier way of, instead of squaring all these huge numbers, and work with these big numbers. Just leave it like that. So this is 19 squared. This is 22 squared. Okay, now I've got two equations with two unknowns. So I can solve. So I've got 4a squared plus b squared equals 19 squared. And then I can multiply this by 4 to try to eliminate b. So I've got 4a squared plus 16b squared. Multiply this. And now this is 4 squared. 4 times this is 2 squared. 2 squared times 22 squared. So that is 44 squared. And so when you subtract, you got 4a squared. Oh, I'm sorry, this is 4a squared. So the idea in multiplying by 4 is to eliminate the a squared. You subtract this way, you get subtract the first equation from the second. The a squareds cancel. You have 15b squared. I subtract this way because then I don't have negatives, you see. 15b squared is 44 squared minus 19 squared. So, see, now this is nice because this is a difference of two squares. I don't have to. So this is 44 minus 19 into 44 plus 19. So that is 25. 44 plus 19 is 63. That is 15b squared. So you can say b squared, you can take out one of the 5s from here. And the 3, you can take it out from here. 5 times 3. So that is 105. Okay, I hope my calculations are more accurate this time. So b squared is 105. And I need to calculate a squared. I got 4a squared. I'm not going to work out b because b is the square root of something. You see, the question is find AB. Find the length of AB. So we can work out AB squared. Again, using Pythagoras on the large thing, is 4a squared, 2a all squared, plus 4b squared. So I really need a squared and b squared. I don't need a and b. And I've got b squared, so that's fine. Now I need to get a squared. I've got 4a squared is 19 squared minus b squared. From here. And now this time you really need to work out 19 squared. 361 minus 105. And that gives you 256, which is nice because then a squared is 64. All right, 361 minus 105 is easily seen to be 256. 4a squared is that, so a squared is 64. So you got a squared, and you got b squared. So therefore, this will be 4 times a squared. Well, 4a squared is 256. I just put 256 plus 4b squared. B squared is 420. B squared is 105. So 4 times 105 is 420. Now 256 plus this is 676. And 676 is a perfect square. AB squared is 676. And it turns out that 26 squared is 676. All right. I don't know whether would have been possible to do this thing without having to know that the square root of 676 is 26. Um, but it's not so difficult because you see, 676 is 4 times 169. If you take out the 4, and 169, I think all of you know, is 13 squared. This 2 squared, so 13 times 2 is 26. So AB squared is 26 squared. So AB will be 26. Okay, so if we go on to the solution, which I had already worked out. Oh, I had a much better solution here. You see, I didn't have to calculate these things. I've got x squared plus 4y squared is this, 4x squared plus y squared is this, and I need to get x squared plus y squared, right? Or in this problem, what I did was I wrote down that Cm is x, and I got this as y. So I need to calculate 4x squared plus 4y squared. But I can see when I add, I'll get 5x squared plus 5y squared. And that makes it very easy because if 5x squared plus 5y squared is, you simply add them, then you got x squared plus y squared, and therefore 4x squared plus 4y squared is, you can work it out, it's 4 times 169, and therefore the square root is 2 times 13. Ah, this is much more elegant. Okay, I missed that one. Mm. So let's get on to question 6. Question 6 says the two upright trees of heights 10 meters and 14 meters So let's draw these trees. I don't have much space here, but I think I have created space. So you got, these are, you got trees. One is 10 and one is 14. They got a short tree and a long tree, or a tall tree. Now, there's a big story here. The distance between the bottoms of the trees is 16 meters. So this is 16 meters. A sparrow sits at the top of each tree. The sparrow is sitting there, and is sitting there. Both sparrows spot the same worm somewhere between the bottoms of the two trees. So these sparrows, they spot a worm here. And at the same time, with the equal speed, they dive directly for the worm. So this sparrow directly goes for the worm. And this one also goes for the worm. Reaching it simultaneously. And the question is, what is the distance from the worm to the bottom of the shorter tree? So this is the shorter tree, and this is the taller tree. So the question is, what is the distance from the worm to the bottom of this tree? So we can call this x. This whole distance is 16. So this will be 16 minus x. Both the birds leave at the same time, and they reach it at the same time also. So that means that whatever this length is, this divided by the time is this girl this bird's speed, and this divided by the same time gives this guy's speed. They both have the same speed. So that means that these two lengths are the same. Distance times time, speed times time is equal to distance. And the birds have got the same speed and they take the same time to reach them. So these two are equal. Right? Which means I can get an equation. Namely, Pythagoras applied twice gives you the square of this, which is the same as the square of that. So it's 10 squared plus x squared is equal to 14 squared plus this squared. Okay. So what I've done here is, let me just go to this blank page. So what I've got here is ten squared plus x squared is equal to the square of this. But this is the same as that because the birds, they travel at the same speed and the same time. So therefore, they would have covered the same distance. Is equal to 14 squared plus 16 minus x all squared. So this is 196. See, it's useful to know some of these squares here. Like I know all these squares. 16 squared is 256. Minus, you got a square of a binomial. Multiply these two and multiply that by 2. You get minus 32x minus 2 times 16x plus x squared. The x squareds happily cancel. If you bring all the x's to one side, only one x's to bring. That's 32x. And then you have 186 plus 256 minus 100. If you take this to the other side, so this gives you 352, I think. Because you got 256 plus 96, which is 352. So therefore x is equal to 11. So the question is now, what is the distance from the worm to the bottom of the shorter tree? And we call that x. So there's the shorter tree. So the answer is 11. As you can see, right at the bottom, we've got x equals 11. I let x be the distance between, in this problem here, between the bird, the worm, the hapless, unfortunate worm, to the taller tree. I should have made x. But anyway, we come to the same answer. All right, so that takes care of that problem. And let's go to the next problem. Question 7. A village consists of 9 blocks of houses. I'm not going to go through the whole story. I can tell you what it is. You got a guy who is sweeping. He starts from one of the corners of the village. He's a sweeper. And what he does is he sweeps all these roads. These are all roads. Right? He sweeps all these roads and he comes back to his starting point. Now the question that is asked is, what is the shortest path he can take? He doesn't want to go around like this, go around like this, and go around like that. That'll take a long, long time. What is the shortest path that he needs to take to get back, starting here and ending here at the same starting point? Now, if you try this now, you'll see that You can say, all right, let's say it starts here, and then it goes up like this, goes there like that, looking for the shortest path, like that. Now, when it does that, you come here, so you have to backtrack. But you got all these in between roads haven't been done, right? So you have to do a lot of backtracking if you take this particular path, because then you have to backtrack along this and then cover that one there, then come back along this and do that. So you'll be doing a lot of double covering, as it were. So we have to ask ourselves, what is the shortest path? It's not very easy, but in other words, you must reduce the number of backtracks. See? And it turns out that you need to backtrack only on this one, on that one, that one, that one. Only 4 backtracks you can do. There is a pathway to do that. And I think it's going to be the following. It starts here. And it goes here. It goes like that. Goes here. See, he has to come back to the starting point. Right? So goes down there. And then he tries to cover this one here. See, I told you have to cover these. Tries to cover this one. And then backtrack and go up. Go there. And then he covers this line here. See, he finish the middle, and then he backtracks on this. Then he goes up. Then he goes up, covers this road here also, and then he backtracks on this. Does this, and then comes back. And there we go. And he comes right down to the starting point. You see, he's already covered this part here. So it's only those 4 which have got. If you work out the full length, what is the smallest distance between the dustman can travel? They said each one has got side 1. So you just have to work out the full pathway. This is 3 plus 1 plus 3 and so on. And eventually you can work out. See, the minimal pathway will be 3, 6, 9, 12, 3, 6, 9, 12. So there will be 24 altogether. So he only uses 4 extra, so it should be 28, right? Because he backtracks only 4 times. Oh no. So there it is. There's a pathway. I named it as A, B, C, D, E, F. So you just follow the letters of the alphabet to figure out what the pathway is, and you will see that this is what I've done. I have to say that I didn't solve this myself. I checked the answer because it's not an easy one to recognize that there are only 4 backtracks, which will minimize this thing. Okay, so let's go into the next problem. Which is question 8. Question 8 gives you a simple triangle, and EF is parallel to BC. It's given that these lines are parallel. There it is. And CD and EF are equal, as you can see. But AC is 5 times longer than CD. So the CD, so if CD is, oh, okay. So this is 5 times longer. So if this is A, and if this is A, so AF is, what do you say? AC, the whole thing is 5A. All right, if the whole thing is 5A and these together make 2A, so this AF will have to be 3A. All right. Now they say find the area of the trapezium. Of course, these two lines are parallel. So the trapezium they're looking for is this trapezium here. They say find the area of this if the area of BCD is 1. So this area here is 1. So what is the area of the trapezium? Now, to do this, you have to know a certain thing which keeps coming up in these competitions. If you've been looking at my other posts, you will see, you will know this formula. It's very simple. If you've got any triangle, you've got a line joining one vertex to some point on the other side. So this vertex line, it divides the other side into a certain ratio, but it also divides the triangle area in some ratio. So it turns out that these ratios are the same. If you have this side, these sides are A and B, and these areas are A and B like that, those are areas, then the area of A over the area of B is the same as this. And the reason for that is quite obvious because the area is half base times height, you see. And both these triangles have got the same height. The height from here to here is the height of A as well as the height of B. So when you're working this out, half the height cancels and you'll end up with this. You can try it. Okay, so what's important is the area is the same as the ratios. So now these two are equal. So let me just join this. To say that this ratio here is 1. So this will also be 1. So these two areas are equal because these two sides are equal. A over A is equal to 1 over something. So that has to be 1. All right. And then the other thing is you've got, if this is, so this whole thing here is 2. So this entire thing here is 3 because this 2A, 3A. So the ratio from this to this is 2 over 3. So if this is 2, ABF is 3. Okay, that's quite useful to know. Let's call these, well, since these lines are parallel, then if this is B, then there's a theorem which says that a line parallel to a side, it divides the two sides in the same ratio. This thing here to this is 3 over 2 AF over FC is 3 over 2. It's the same as AE over EB. This always happens when you got parallel lines. This line is parallel to this. So this ratio, this over this is the same as that over that. So, okay, we can call this 2b, we can call this 3b. Okay, so, I'm sorry, these are the sides, not the areas. The sides. This side is 3b. The ratio here is 3:2. This ratio will also be 3:2, but it's not 3a over 2a anymore. It's the same ratio, so you can call it 3b over 2b. Okay, so what do you have? You have that this area here is actually equal to, well, okay, this is 1. So the entire area here will be 3. This entire thing is 3. So the areas are split. This entire area is ABF over 2 is the same as 3 over 2. So therefore ABF is 3 units. But these two, this 3 units is divided in the ratio 3:2. So how do you divide 3 in the ratio 3:2? So you'll have to have 3/5 of 3, which is 6/5. So this is 6/5, which is 1,2. And the other is 2/5 of 9. This is 2,4, I'm sorry. 3/5 of 3. So this is 3/5 of 3 is 9 over 5, which is 1,8. Sorry, I'm making all these errors here. So this one here will have to be 1,8. And the ratio of these areas is 3:2. So this will have to be 1,2. Okay. So the area of the trapezium is 3,2. Somehow it doesn't look right. So you got this area is 2, this area here is 3, and the ratio is 3/2. It seems to be okay. And the area of the trapezium is 1,2. So the area of EFCD is 3,2. You add up all these areas. Right, the key point is to notice that this area to this area is 3/2. So it will be equal to this entire, you see, this becomes your Servian, or the line that joins the vertex to this point. So this entire area over this area will be 3/2. This is already 2. So that area, the entire area there will be 3. But that 3 is now divided up into the ratio of 3:2. So it becomes that. All right, let's see. I might have made some calculation error here again. Oh, actually, that's the same answer. I said 3,2, isn't it? So we've got B is equal to 3/5. So this is 3/5, which gives you 9/5. This is 2/5. Oh, I see. This is 2/5. B is 3/5. So 2B will be 6/5, which is 1,2. Okay, so it's 1,2 plus 1 plus 1, and that's 3,2, not 4,2. Okay, 4.2. So the answer is 3.2. All right, so it looks as if that is the correct answer. Let's get on to the next problem, which is question 9. Question 9 says, the letters of the word travel are randomly chosen to create new 6-letter words. The words need not be meaningful. What is the probability of using a letter more than once in a 6-letter word? Okay, this is a counting problem. And the way to solve these problems is to find out in how many ways can you do each of these actions. So I'm going to make a word from travel by randomly choosing new 6-letter words. So I want to make a 6-letter word. So I will choose the first letter. I got TRAVEL. I got 6 letters to choose from. So in that first block, I put 6. Means that this block can be filled in 6 ways. That's the first letter of the 6-letter word. The second letter, 6th word can also be chosen in 6 ways. Right? And the third one can be chosen in 6 ways because you allow repetitions. So the number of words altogether is, and you multiply all these things. And this is called the first rule of counting. Right? If you can do something one step in m ways and another step in n ways, then the two things together you can do it in mn ways. See? And my standard example is that if you got 2 towns and you can go from one town to the other in 3 ways, you can go this way, or that way. And from the second town to the other, suppose you can do it in 4 ways. Then how many ways can you travel from A to C? For each choice here, you got 4 choices on this side. So you got another 4 for this, another 4 for this. So that makes 12. So it's actually 3 times 4. So if you can do one thing in m ways and another thing in n ways, then to do the 2 things together, in other words, travel from A to C, then it's mn ways. So that's the logic behind this. So yeah, you can extend that logic to bigger situations and you'll get this. Now, what is the probability of using a letter more than once in a 6-letter word? So in other words, we are saying that you can use it 2 times, the same letter, or 3 times, or 4 times, or whatever. Right? So the way to do that is to say, oh, okay, look, suppose you say, I'm not going to repeat any letters. Calculate the number of ways in which repetitions are not allowed. Right? So if you say if the, say calculate the number, say m of ways where the repetition is not allowed, then your answer will be 6 to the 6 minus m. So you eliminate all those where the repetitions are not allowed, then you will get those where the repetitions are allowed. Because you say, what is the probability of using a letter more than once? So the repetitions are allowed in the question. And to work out the number of ways the repetitions are not allowed is do the same kind of a calculation. And now I make my word. I'm not allowed to repeat, you see. So the first letter can be chosen in 6 ways. But the sixth letter cannot be chosen in 6 ways anymore, because you're not allowed to choose the first letter. So you can only choose the second letter in 5 ways. Now you chose the first two, not allowed to choose either of those two because repetitions are not allowed. So you only have 4 choices. So like that, if you do all this, you'll see at the end, all the 5 have been chosen, and you only got 1 left. And if you multiply all this, you get the number of ways m is 6 to the 6 minus this product. The product of 6 times 5 times 4 times 3 times 1 is what you call 6 factorial. So this is, it's actually 720. See, so that'll be your answer. So if you want to get the, but the question is, what is the probability? Right. In other words, this is the number of ways in which repetitions are not allowed. This is the total number of words altogether. So the probability that we are seeking, the chances is this number, the number of what we call successes. 1 times 2 times 3 is 720 over 6 to the 6. Because this is the total number. And this is the number of situations where repetitions are allowed. I've removed the ones where they are not allowed. So the rest of it are allowed. And if you work this thing out, you see this is 36. 6 times 6 is 36 times 20. So this is 6 squared to 6 to the 4th minus 20. Because this is 36 times 20. 6 squared. So you have 6 squared cancels off with this. And you have 6 to the 4th over 6 to the 4th minus 20 over 6 to the 4th. Okay, so if you work this thing out, you get 1,286, 6 squared. Divide by 4, you get 5. 1 minus 5 over 324. Because 6 to the 4th is 6 squared times 6 squared. And then I'm canceling the 4. 4 goes into this 5 times. So 6 squared is 36. So it's 9 times 6 squared is 36. 9 times 36 is 324. That's where I got this 324 from. And then so that is 319 over 324. So that's a probability. 319 over 324. So if you check this thing out, oh, there it is. You see right at the bottom of the page, you'll see it's the same answer that I've got.